All right, time for a second example of what I'm going to call work rational equations. There is a document on LMS which is called Chapter 7, Applications of Rational Expressions, or something to that effect. It's a PDF. You could pull that up and print it out if you would like to go along with my example. The example that I'm doing, if you have printed that out, is example 6. It's on what would be page 376 of that book, and it's called Shoveling Snow. And that's where we're going to start. This is another example of a work type problem, shoveling snow. So it says, after a heavy snowfall, Brian can shovel all of the driveway in 30 minutes. So it takes Brian 30 minutes to shovel the whole driveway. If his younger brother Alan helps, the job only takes 20 minutes. So Brian plus Alan equals 20 minutes. And the question is, how long would it take Alan to do it by himself? Okay, so the first thing that we're going to do is we're going to figure out rates. So we're going to start with Brian. Work equals rate times time. Okay, Brian's work is one whole driveway. His time is 30 minutes, and we don't know his rate, so we divide by 30, and the units on the one is job or driveway. I'm just going to write job because it's slow or quicker to write. So Brian's rate is 1/30 of a job per minute. Does that make sense? He could do a whole driveway in 30 minutes, so his rate is 1/30 of the job per minute. Let me slide that over a little bit better so you can see it. All right, now let's talk about Alan. We don't know how long it takes Alan to do it, but Alan's work would be one whole driveway. We don't know his rate, but we know the time it would take him would be X minutes. Okay, we're just going to call it X minutes. So his rate is 1 divided by X, where X is the number of minutes for Alan to do it by himself. Are you with me? All right, and if you're not with me, you can text me, you can post on LMS, you can call me. I want to be here to help y'all during this goofy time. So anyway, we have Brian's rate is 1/30 of the job per minute. Alan's rate is 1/x of the job per minute, and together it takes them 20 minutes. Okay, so Brian's work plus Alan's work equals one whole driveway. Okay, now how long do they work? They work 20 minutes. So let's do Brian's work. His rate is 1/30, so work equals rate times time. So 1/30 is his rate. His time is 20 minutes. Okay, Alan's rate is 1/x. His time is 20 minutes, and together they complete one job. Okay, so I'm going to multiply these two together. So 20 over 1 times 20 is 20, 30 times 1 is 30, that's 20 over 30, or you could reduce, 10 goes into that 2 times, 10 goes into that 3 times, so that's 2/3. So we know if Brian can do it in 30 minutes, in 20 minutes he does 2/3 of the work. Okay, so there's 2/3 plus 1 times 20 is 20, 20 over x, understood 1 down there, x times 1, and that equals 1 whole job. So Brian does 2/3 of it, Alan does 20 over x of it, and that equals 1. Okay? I want to solve it like a rational equation, so I put brackets around the whole thing. The common denominator of 3 and x and an understood 1 is 3x. That 3 will go into 3x and leave me with an x. In other words, x is the extra I need. X times 2 is 2x. X goes into 3x and cancels the x and leaves me with a 3. 3 times 20 is 60. 1 goes into 3x. 3x times 1 is 3x. And now I have 2x plus 60 equals 3x. Move the 2x to the other side by subtracting it. So 60 equals 1x. And there's nothing else to do. Dividing by 1 doesn't change. So x equals 60, and x is in minutes. Now let's think about what that means. X is Alan by itself. Okay? So in other words, it'll take Alan 60 minutes to do the whole driveway by himself. Now let's see if that checks. Okay? They're working for 20 minutes. And it would take Alan 60 minutes to do it by himself. So 20 divided by 60 is 1/3. So Alan can do 1/3 of the driveway. Brian, it takes him 30 minutes to do it, and he has 20. So 20 divided by 30 is 2/3. So Brian does 2/3 of the driveway, and Alan does 1/3 of the driveway, and altogether they do a whole driveway. So the question was, how long would it take Alan to do it by himself? And the answer is 60 minutes. Okay. Now, if you'll look on that PDF, on page 376, there's strategy for solving work problems. I would like you guys to write these out and have them in your notebook. I should have told you to copy out that example. If you didn't copy out that example, go back and watch it again and copy it out on notebook paper, and you can call it work example, shovel and snow example, whatever you want to call it. So a strategy for solving work problems. Step 1, if a job is completed in X hours, then the rate is 1 divided by X job per hours. And think about that. One job in X hours. Okay. Number 2, make a table. They make a table. You can make a table if you want to, but you're going to use this formula. Work equals rate times time. And they make a table that looks something like this. So they put like person 1, person 2, however many people you've got. And then they put their rate. And then they put their time. And then they put the amount of work that they perform, which is rate times time. And then all their work will add up to one completed job. So the third thing that they say is the total work completed is the sum, which means add, of all the individual works and then number 4, if a job is completed, the work equals 1. One job. Okay, so we have done 2 examples of work problems. If you want to at this point in time, you could stop the video, you could go to the homework for today, which I have listed on LMS, and I'm getting it here so I can look at it. And you could do a work problem. Problem number 39 is a work problem. Problem number 42 is a work problem. So you could work those two right now from your homework, which is attached on LMS. So we've done 2 examples of rational work problems. And now I'm going to stop this video and we're going to get ready to do another type of example. Thanks, guys. I hope this is making sense for you.